All right, so since now you guys have an understanding of math operators, and we've been kind of using them in multiple different ways up to this point, but now we're going to use them in a couple different ways. We are going to create some functions, and ultimately what we need to have is we need to show that we have an understanding of modulus. So modulus, and that pairs well with division. So modulus and division, addition, subtraction. Okay, on and let's do one for squaring, which is using exponents, so exponentiation. So squaring and raising to a power. Okay, so the way that we can do this, and this is not going to be so graphically based right now because there are ways that we can do it, but with this the web editor, we can actually start typing stuff in here and run code directly through the console. Okay, so as long as we have created a project, we can do stuff. So I'm going to walk through. We have talked already about using custom functions for creating like the mouse press or making it event-based. We are going to go ahead and create some, but we're going to actually have parameters of things that we have to put into it. Okay, so if I end up typing a function, and you guys are going to end up following along with this. This is a walkthrough. Okay, I'm going to walk through these functions, and then you guys will have challenges later on. Okay, so we'll start with function, and maybe we just want to say hello, and then we have to have our squiggle brackets. So when I'm looking at this, I have to type it with the keyword function, and then I give it a function name, set of parentheses, and set of squiggle brackets. Anything within there is going to be part of that function. So if, let's say that I'm just doing console log hello, and we go ahead and run this. So notice I have my auto refresh on. I'm going to type right where this caret is, the exact name, case sensitive, put parentheses, and then click enter, and what do I end up seeing? The first thing that I see, it's going to end up doing this little return where it's going to say undefined, which we'll talk about, but it will actually print hello. So I could say hello Bob, and I could call this out, hello, and it's going to say hello Bob. It's printing back. Okay, that doesn't really do much for us right now. If we didn't want it to say that undefined, instead of us actually printing to the console, we can actually choose to return a value, which is useful because if we call the value, we can have it actually return something, and we could store it as some other variable. So I could just say return hello. Now if I'm running this, and I look, and I call this out hello, it's returning hello with that cap. Now that is a function, just like our draw and our setup, that does not require any parameters. So I don't have to put anything in there. But if I wanted to put something in there, I wanted to return something specific. Like if they put their name in there, I could return with that. So maybe, I'm writing name. This would be a temporary variable that I'm creating that only exists inside of this function. So instead of it saying hello, I can have it say hello name. Now when I call this function hello, and I got to use quotes, Bob, now it's doing hello Bob. It doesn't have the space because I have to be explicit on putting the spaces in. I can go ahead and rerun it again. Hello Bob. It says Bob is not defined because I have to type it inside of quotes since I'm giving it actual text. So Bob Single quotes or double quotes would work. So now it's returning hello Bob. So this is pretty cool. So now that you guys kind of have this idea, we can choose to return. I'm going to actually write this different. This is called concatenation. When I have a string and another string, I can pair them up together like putting two cars together from a train set. But what I actually like is a string literal, which we've talked about this before in the helper code. You're using a backtick, so it's the key to the left of the 1 and above the tab key. It looks like this. A single quote looks like this. A backtick looks like this. You have to use the backtick. But I could say, and just write out what I want, and then I just introduce my variables. So hello, space, and then if I want to use a variable, I use a $sign and squiggle brackets. Anything typed inside that squiggle brackets would be what is a variable. So this, to me, is a lot easier to understand because I already have the spaces and everything put in there. So I can say, hello, Tim. Again, I got to make sure that I'm putting in quotes. That gets put, this Tim is a string, gets temporarily stored as this variable name, and then in here I can use it. All right, so when I run this, now it's returning hello Tim. Okay, so this idea, this function, makes it a lot easier for us to run it. Okay, now let's go ahead and actually start doing this with the addition. So now we're going to do addition, which means that we're going to require two values. So let's just do add numbers, and we are going to have to give it two values. Now I'm going to do v1 for my value 1 and v2. Inside of my squiggle brackets, what do I want it to do? Ultimately, I want it to do this. Now, I could store this as a temporary variable, but since I don't need it for anything other than I just want to return what it is, I'm just going to do the math on it. This plus, because these are both not strings, they are numbers, I can look at it and say, well, all right, just add them together. Add numbers 30, 22. And it gives me a total. All right, all that is doing right now is just returning a value. Okay, so this is pretty easy. I could do now in cases depending on what I need it to return. Sometimes I might need it to actually just return a number so that I can use it in something else. Maybe I want to check if it has hit a boundary. I can run this a function and just check the value. Other times I might actually just want to return a string. Okay, so I can actually build it like this, which makes it a whole lot easier. So let's go ahead. You're going to end up doing a subtraction one yourself. Okay, but it does need to be written in this way. Okay, v1, v2. Okay, so that I can check that you guys have it. So you need to fill in some code here, fill in code here for subtracting. Now we need to do another one. We're going to do squaring, and we're going to find out that some of these are going to be very, very similar. We can actually have functions call other functions. So let's do one for squaring. And we want to do one for doing a like raising to a power or exponentiation.
Good morning.
Okay, a good programmer always is going to try to write code less. So let's look at these because it would make sense if we are developing these in the correct order. Squaring, that's like I'm doing, say, 5 squared, that's 5 raised to the power of 2. If I am writing a function to raise something to a power, I have my base, and I'm raising it to a certain value. Squaring is a more specific use of raising something to a power because I'm just doubling that number. So instead of me saying 5 raised to a power and then finding out what that power is, I am just squaring it. So I'm taking that base and I'm just raising it by 2. So if I was looking at this in terms of development, it would make more sense for me to develop this one first and then use this to this one. When I create this, I'm going to call a previous value. Okay, so let's go ahead and switch the order. Okay, so now we have learned before that we can do, the base multiply two multiples and then the power. That's how we would raise to a power. For squaring, we're doing base raised to 2. There's also another way that we can write this. Let's go into the reference and look, because there is a math section, which is useful for us to do lots of stuff. Okay, let's look at this one. Let's look at this one. Okay, exp, that's the Euler's number, so that's not it. I thought that might be an abbreviation for, let's move this, exponents. Power, though, POW, it's an exponential expression. The power function is an efficient way of multiplying numbers by themselves or the reciprocals in large quantities. For example, power of 3 comma 5, that is 3 raised to the power of 5. It's equivalent to the expression of 1, 2, 3, 4, 5, or 3 raised to the power of 5. Okay? So this is my base, and this is my exponent. So this is just another way of us writing it. Either one will get us there. Okay? So I could write it, like this. I could also write it as POW, and then it's base, comma, power. They both will do the same thing. All right, so let's build this raising to a power. So function, since we already technically have this, we already have this. I'm going to go ahead and write it this way, but since we already have this, this is going to like what we're ultimately leading into. So functioning, let's call it doPower, I guess. We're going to call it base, comma, power. Using variables that make sense in the calculation, just like what we did, we just modeled it out. We can do that. So return base times power. Okay, I can let those do the math for me. So I can just say do power, and I could say maybe 5 comma 2. We get 25. Do power. Let's do 10 comma 10. That's pretty big. Do power 3 comma 3. So that should be 3 times 3 times 3. 27. Okay, so that works. Now the other way that we could write it, let me comment this out. So I'm still leaving it there, but we can write it the other way. Return, and we'll do POW, and then it's base, comma, power. Same thing, okay, as this. They both do the same thing. Do power. And let's do 5 comma 2, 25. Do power, 4 comma 3. So it'd be 4 times 4 times 4, 64. Okay, so that's how we would do it. Now, we understand that part. Now the squaring, that is always going to be doing where it's always 2 as the power. So I could write a new one, and in this one, let's call it squaring. Okay, and in this case, we only need one parameter, because the base, the only thing that's changing is the base. Okay, so instead of me now building this, this would be pointless. Okay, pow base comma, and then doing this is technically is redundant. They're almost doing the exact same thing. Okay, even though this is squaring by 2. So if I'm doing this squaring and I do 5, that's giving me it. Now I'm basically calling this. So since it's already being called, what I should do is I should actually just call this and provide it. So this would be the better way. doPower. Now I'm exponents, it's a pretty simple example. If we had a much heavier calculation, it would make sense that we are breaking it down logically by its simplest pieces. And so if I have a specific case, then I'm passing in that specificity. Okay, so now if I'm doing squaring, let's say 25, that is doing 25 squared. So squaring 5, that's doing 5 as my base times 2. Okay, these I am calling another function, this function, which is calling this function, but here I'm giving it some of the specific pieces of information that I need. So this makes it a lot easier for us to start planning stuff. So this squaring, really that can be, a way that I'm calculating the area. This is returning a value, okay? So let's look at this one. I want to do one that's calculating the area of a square, okay? What is the area of a square? Well, it's going to be base times height, right? So in here, if I'm going to be doing this, what do I have that I would need? Well, I could pull the base and the height, but it's the area of a square. So if I'm using something like this, I could reuse this function that is just taking the base, since the base and the height are the exact same thing, I could use that to my advantage. Okay, so instead of me saying base times height, it is base times base, which is the same thing as just base squared. Okay, so let's go ahead and write that. But in this case, I want to write and return, they put in the area. So let's do a new function, and we're going to call it area of square. Okay, and I'm going to have to give it a side. All right, now the side is the same, but what do I want to return? I want to return, and I'm going to use the backticks, the area of a square with a using that variable long side is, and then I can call this function, the one that we've previously wrote. I'm going to put it inside of here. So that is the squaring one. Squaring, and I'm putting in that side. Okay, that is going to return a value. From here, we already seen it's going to return a value, and I can actually put that in this phrase. So it's going to return this entire phrase. So area of square, let's do 5. The area of a square with a 5 long side is 25. Okay. 5, I mean, we could put, unit. That makes sense. So area of square, 10. The area of a square with a 10 unit long side is 100. Okay? So I've done multiple ways that we can use functions and call previous functions to make it so that we can better write our stuff. The ones that I did not do is I did not do, so we did an addition. I did not do a subtraction. We raised to a power. We wrote it multiple different ways where we even commented out the other way. Then we did a specific case for raising just to a second power. And then we used that to be able to do the area of a square. So the other ones that we have not done that I want you guys to do, you've done subtraction is one that you're going to have to do. I want you to do modulus and division. What I want it to output. So we input, I'm giving you specifics in pseudocode, input two numbers, okay? First number is the number that we're dividing, number dividing. The second number, or the second parameter, is the number dividing by, okay? I want the output for this to say that first number, so I'm going to write it explicitly, but you guys are going to end up having to use a string literal with the backticks and put this in. A couple hints. The process between your input and output is probably going to end up having to have two in function will need two temporary variables. One to hold like how many times it was divisible, and one to hold the remainder. Okay, now, so our output, before we talk about this a little bit more, our output will say, so I'm going to put it in parentheses, num1 divided by num2 is blank with a remainder of blank. Okay, so you guys are going to have to create this. Again, you cannot write it just like this. You're going to have to put it in the proper code. Okay, here is another little clue. If I am running and I just put two numbers for JavaScript, it's not going to do this. It's going to give us actual decimals. So one of the things that we are going to probably need, if I want to say 9 divided by 3, I know that goes in 3 times. It has a remainder of 0 because there's nothing left over. If I say 9 divided by 4, let's look at that. 9 divided by 4. Okay, that is giving me decimals. But if I'm just asking division, in this case I want to know how many times it went in, I don't care about this fraction. I want to know what's left over. Well, we know that 4 goes into 9 evenly 2 times. Don't care what's left over. When I'm doing the modulus piece, I want to know how much is left over. So 9 modulo 4 would have a remainder of 1 because there is 1 left over after 4 goes in as many times as it can. Okay, so I actually have to break this up into 2 pieces. One of the ways that we can do that is let's look at our math operators and see what's in there. Okay, now there are multiple ones that we could use. Ceiling is one, constrain is one, floor is one. What you would probably want to do, round is one, but since this case, if it gives us a decimal, it means that there is something left over. I don't care what that leftover is when I'm just doing the division. So that means that I need a function that is not going to try to change what that original value is. It's just going to get rid of the decimals. Now if I look at ceiling, ceiling will just go up to the next whole number, which isn't something that I necessarily want because then that would give me more than what I want. If I look at the other ones that are available, let's look at floor. Floor, let's see if that's giving it. So if I have 1.44, that's just giving me the whole number. That seems like something that I would want, because 2.25 just goes down to 2. So I just have to put that calculation inside of the floor, and it will return that whole number. Okay? So you'll probably want to use floor in the calculation. Okay? So in terms of everything that we need to do, we have talked about modulus and division, addition, subtraction, squaring, and raising to a power. Okay? I have personally walked you through using functions and using parameters to be able to return stuff, and using our console to be able to see that stuff. We have walked through addition. We have walked through raising a power, deciding which one I'm going to create first, writing it multiple ways. We've then used the squaring function to call that raising a power function. And then we used another function called the area of a square to print out actual phrase based off of those two functions. Okay? What you need to do is you need to create a function for subtraction, and you need to create a function that's using modulus and division. It takes two numbers, and it's dividing the first one by the second one. It's going to end up having to do some calculations inside and probably use the floor function, and it's going to output this exact phrase when I type it. Okay? Good luck. Have fun.